Welcome friends. So, we are seeing the use of analytics in different areas of decision making in operations management, and as we started in our last class about the use of analytics for inventory management, which is another very important area after forecasting. We discussed a very simple case of EOQ. However, in the last of the session, we discussed that the practical life, the practical scenario is not so simple. There are different types of uncertainties which are very common in any scenario. We discussed that uncertainties may come from the supply side, uncertainties may come from the demand side also. So, in this particular session, we will be focusing about how are we going to manage those uncertainties and have a better decision making for fulfilling the objectives of the organization. You remember that with inventory management, the important things which we are looking, one is a service level. I want to keep inventory so that whenever a customer requires a product, I should be able to fulfill that customer's requirement. I want to achieve a particular service level, higher and higher service level. And on the other side, cost of keeping inventory should be as low as possible. These are my two objectives: improving the service level. If you want to keep very good service level, you should have infinite amount of inventory. Mathematically, that is the answer. But no company in the world can have infinite amount of inventory of any product. And as we all know, in this current environment, SKUs are increasing. SKU stands for stock keeping units. So, these SKUs are continuously on rise, and therefore, there will always be a pressure on the company that optimize your physical space. Inventory takes physical space. So, you have to optimize your physical space. With that, you need to achieve higher service levels, and at the same time you need to keep the cost as low as possible. So, in this particular session, we will be talking of demand uncertainty. What are the different kinds of measures of service level? How are we going to determine the safety level, cycle service level, and calculations of safety stock for a particular service levels. So, let us first understand how are we going to measure the demand uncertainty. And for measuring the demand uncertainty, we generally assume, and you will see that it is not about assumption, but every time you can see that demand is considered to be normally distributed. And when I say demand is normally distributed, I hope all of you are very much familiar with this normal distribution. And in this normal distribution, as you are seeing that there is a bell shaped curve, and this bell shaped curve has total area under the curve. This total area is under the curve equals to 1, and this center line is the result of our characteristics of the data, it is mean. And as you see that curve is spread around the mean line, so this spread is basically coming because of its standard deviation, that is sigma. So, here you see that I have written 168, 95, 99, 5 rule. This means that when you are moving around your mean, area under the curve will increase as your sigma levels are increasing. If you are just plus minus 1 sigma around the mean value, you have 68% of area. If you are adding another 1 sigma on either side, then it becomes 95% area, and then if you add one more sigma, this one more sigma, then this is 99.5% area. So, we have tried to explain you in the form of this diagram also. In our last session, we got familiarity with respect to this sawtooth pattern. Now, the consumption rate which we are saying, it is a smooth line in our last class, but actually it is not a smooth line. It can very well be represented as a normally distributed line, where this line which we are drawing, this is the mean line, and actually it has variation around this. That is what I am trying to show in this diagram. So, these are the variations, and then also you have 68, 95 and 99.5 rule applicable in this case also, where capital D is representing average demand per period and sigma D is the standard deviation of demand per period. We are assuming L as the time between an order is placed and it is received, that is the lead time. There may be a variation in lead time also, we will be discussing. Now, if we consider the average demand per period is 10 units per day and standard deviation of demand per period is 2 units, lead time is 10 days. So, here the demand during the lead time DL becomes 100 units, that is the demand during the lead time, that is 100 units. Now, per day demand is 10 unit, and in that 10 units the standard deviation is 2 units, like this way. 10 is the average, and then if you draw, it may go up to 1 sigma, 2 sigma, 3 sigma, 1 sigma, 2 sigma, 3 sigma. So, this is 2, 4, 6, this is also 2, 4, 6. That means, demand can vary on any day from 8 units to 12 units. This has a probability of 68%. Demand can vary from 6 units to 14 units, the probability is 95%, and demand can vary from 4 to 16 units, the probability is 99.5%. That is how you will read this rule of 68, 95, 99.5 and the meaning of this normal distribution. Now, the average demand, the demand during the lead time, that is the average demand during lead time is now 100 units, and standard deviation of demand during the lead time, that is not possible to add like this or multiply like this. You have to first calculate variance of daily demand. If standard deviation is 2, so variance of daily demand is equals to a square of standard deviation. So, here this is the standard deviation of demand during the lead time under root 10 into 2, 6.32 units. That is our first, you need to calculate the, so the formula for sigma D, sorry not sigma D, sigma L for the period of L days, you have to do the sigma D square L times, and that it can be simplified as under root L into sigma D. That is what we have shown in this bottom of the slide. So, this is how we have calculated the amount of uncertainty, and now if I say in another words, this is for daily demand, this normal distribution is for daily demand. Let me make the normal distribution for the demand over the entire lead time, normal distribution for lead time. So, the shape will be like that only, but the values of average and sigma will change. The value of average will be 100 in place of 10 here, and the sigma is now 6.32. So, 1 sigma is 6.32 plus 2 sigma is 12.64, 3 sigma is 18.96, and that is in the negative also, 6.32, 12.64 and 18.96, and you can appropriately find what is the 68% probability, what is the 98%, what is the range for 95% probability, and what is the range for 99.5% probability. After understanding the measure of uncertainty, let us understand the measures of product availability also. Product availability can be described in different ways. One of the very common way of describing the product availability is product fill rate, FR, product fill rate. Now, this product fill rate is that you are coming to a particular outlet and a product is supplied to you from the available inventory. That means, you already have the stock, and from that available inventory you are fulfilling the requirement of the customer. So, that means, if I am having a stock of, let us say, Q items, I am having the stock of Q items. So, the probability that the demand in any period is less than Q, that is my product fill rate. So, these product fill rates etcetera are actually measured in terms of probabilities that a customer is going and whether the customer will get the product or not. So, that is the general way of expressing the fill rates. So, here this product fill rate is probability that demand is less than Q or equal to Q. So, as long as our demand is less than Q, a customer is going to receive the product from the available stock. Another important measure is order fill rate, because it is quite possible that in one order you may require different types of products, and let us say there are 5 different types of products in a particular order. It is quite possible that out of 5, 4 are available in the stock, but 1 is not available in the stock. So, I will say that order is not fulfilled. If all the items which are available in the order, they are readily available in my inventory, then the order is completed. So, whenever you have more number of items in your one single order, if only one item is there in your order, then in that case product fill rate and order fill rate are same. But generally we all know that one single order may consist of different types of items, different types of products. So, therefore, order fill rate and product fill rate are discussed separately. So, fraction of order that were fulfilled entirely over a certain number of orders, that is known as order fill rate. And then another important measure is cycle service level, CSL. This is in fact the most common one, most used, cycle service level, that we have so many order cycles. In this sawtooth pattern we see that there are so many orders, so many cycles which are happening continuously. So, in this cycle, whether you have fulfilled all the customer demands from the available stock, in the next cycle also, in the next cycle also. So, out of a certain number of cycles, in how many cycles you have fulfilled the demand of the customer from the available inventory, that is cycle service level. So, cycle service level generally is the more common, because if you have the safety inventory available in every cycle, you will be able to fulfill the demand of the product from that safety inventory. Whenever the demand of the product is crossing the safety inventory limits, then in that cycle you will not be able to fulfill the demand from the available stock. So, therefore, cycle service label is very common and most used in our discussions. Now, let us see how are we going to do the calculations related to safety stock. Like we have just discussed that how we are going to calculate the expected demand during the lead time. If you have the daily demand or weekly demand, D is demand per period. It is not good to write weekly demand, means demand on any period. That period may be month, that period may be daily, that period may be weekly, and this is the lead time. So, D into L is our requirement of the mean requirement of the items. Safety stock is ROP minus D into L. Let us understand how this formula has come. As we already see this sawtooth pattern, and below this sawtooth pattern we have safety stock. Now, here you see that I am placing the order here, I am placing the order here ROP. Now, when this ROP is placed, this is Q by 2 and plus this safety stock. This Q by 2, not sorry, this is not Q by 2, this is ROP which is fulfilling the requirement for this lead time period. This is lead time. So, generally whatever is the inventory required for fulfillment of this lead time, that is D into L. So, this is basically D into L plus this safety stock. So, our ROP is reorder point is D into L plus safety stock, or in another words you can say that safety stock is ROP minus D into L. So, this becomes important relation for determining the calculations of our safety stock. So, with this example you can understand that how we are calculating these things. Our average demand is 2500 units per week. The standard deviation of demand is 500 units, lead time is given as 2 weeks. So, standard deviation given, this is standard deviation for weekly demand. So, for 2 weeks we need to calculate standard deviation in this way, standard deviation for lead time under root 2 into 500, that is our standard deviation for the lead time duration. Now, the order quantity Q 10,000 units and the ROP is 6,000 units. So, you can see the diagram again which will help us in easy understanding. So, our ROP, this Q is 10,000, this is my ROP which is at 6,000, and this is basically D into L and this is safety stock. So, our ROP 6,000 is equals to DL plus safety stock, and DL is 2500 units for 2 weeks. So, safety stock becomes 1000 units. That is what we have done the calculations also. Now, in this case if you want to know what is my average inventory, that is the average cycle inventory plus safety stock. So, average cycle inventory is order quantity divided by 2, 5000 plus 1000, 6000 becomes my average inventory level. And then if you need to calculate your holding cost, this holding cost will always be calculated not on average cycle inventory, but on this average inventory. we can also calculate average flow time in this particular case for how much duration the inventory is there in my stocks. Because if the inventory duration is higher, I have to block my capital for a longer duration. I need more working capital if my flow time is more. If my flow time is less, I am able to generate cash at a much faster rate, which is also very important for a business, that how fast you are able to generate your cash. If your cash generation is happening at a slow pace, you need more working capital to run your operating expenses. So, average flow time in our supply chain discussions, we have a very simple formula known as Little's law. And using that Little's law, you have this I equals to D into T, where average inventory equals to demand into flow time. So, we can calculate the flow time as average inventory divided by demand rate. So, the demand rate is 2500 units, 6000 is my average inventory divided by the demand, 2.4 weeks. That is the average flow time, that a particular item remains 2.4 weeks in our stocks. So, by you can understand, either by reducing the average inventory or by increasing the demand, I can reduce the average flow time, so that I can generate cash at a much faster rate. Now, after discussions of the safety stock calculations, another very important area we need to discuss, that is CSL, cycle service label. Out of various measures of product availability, CSL is the most important one, which is basically the probability of not stocking out in a cycle, which is possible only when the demand during the lead time is less than ROP. You see, here you are with your safety stock also. This is your ROP, and at this ROP level, whatever you are requiring, that is available in the form of DL plus SS. Now, demand during this lead time period from here to here, if this demand is less than ROP, you are able to fulfill the customer's requirement. But if demand becomes more than this ROP level, there may be some customers who are not getting their products. So, demand during lead time should be less than equals to ROP for fulfilling the customer's requirement. So, CSL is basically the probability that demand during lead time is less than equals to ROP. And if you see this diagram on the lower side of your screen, this is simply a normal distribution curve, where we have mean demand as DL, a standard deviation over lead time. This is the standard deviation over the lead time, that is sigma L. So, using Excel analytics, we can simply calculate CSL as the normal distribution, because this entire demand curve is a normal distribution curve. So, normal distribution ROP DL sigma L1, if you put these inputs in your Excel, you will get the value of cycle service level with respect to a particular inventory policy which you are following. Now, using the different combinations, you can see that what CSL you are achieving, or you can do vice versa also. We can use Excel, where you can find that if you want to achieve a particular CSL label, what should be the ROP. So, that calculations are also possible. Now, if you see this simple calculation of CSL calculations, the same data, standard deviation of demand 500 units. Now, first, as I explained, we will calculate the sigma L, standard deviation for lead time period, that is under root L into sigma D, which is coming 707 units. Now, CSL is a function of ROP DL sigma L, and this is put into the Excel format where normal distribution probabilities for this expression is calculated, and that gives you CSL is equal to 92%. That means 92% of the demand will be fulfilled from our stocks in the our case, and around 8% of the demand will not be fulfilled from available inventory. So, in this way the CSL calculations can be used for determining the customer satisfaction level. More CSL means you are able to fulfill the demand of more and more customers. Now, using this knowledge of CSL, using this knowledge of uncertainty, now we have this equation ROP equals to DL plus SS, equation number 1. CSL we have calculated like this, and for this CSL as many time we have a reverse calculation also. If we want a particular CSL, that I want to have 90% CSL, so what should be ROP? That can also be a question, and on the basis of that ROP calculation I can find what should be safety stock also. So, then I will go for normal inverse calculation, then it becomes a inverse function, and that is also possible easily to get in your Excel tables. DL plus SS is equals to this ROP, and then SS can be ROP minus DL. So, all these equations are simply our used equations for CSL and ROP safety stock calculations in our uncertainty cases. Now, using this set of formula, we can have this illustration where again the same data, lead time this, and our sigma L will be under root 2 into 500, that becomes 707. Now, we want to achieve a CSL of 90%, and when we want to use CSL of 90%, let me say that first I will use this ROP formula. So, first I will calculate ROP using the normal inverse function in Excel with this CSL, our DL, then sigma L 1, which I have substituted here, and then this is with available data, it will come somewhere around 5906. So, the safety stock will be ROP minus DL, and that becomes 5906 minus 5000 equals to 906. So, that is how you can calculate the safety stock for a given CSL level, which is a more common calculation in our lessons of uncertainty. So, with this we come to end of this session. Thank you very much.